Today's lesson is going to be on limits as x approaches infinity and negative infinity. So let's start off with doing some problems. So the limit as x approaches negative infinity of 7 over x cubed minus 20. Alright, so first we're going to start off by dividing everything by the largest degree in the denominator. So in this instance it'd be x cubed. So we're going to do 7 over x cubed divided by x cubed over x cubed minus 20 over x cubed. So here we'd be getting a very large number, or 7 over a very large number, which is going to be 0. So we're going to take the limit of this. So this is going to be 0 divided by, and this is going to be 1 minus 0, because it's a number over a really large number. So you're going to get 0 over 1, which is just going to equal 0. So our next problem is going to be the limit as x approaches infinity of x plus 7 over 3x plus 5. So we're going to do the same thing. We're going to divide by the largest degree in the denominator, and in this instance both degrees are going to be x, so it wouldn't really matter. So we're going to do the limit as x approaches infinity of x over x plus 7 over x all over 3 over x plus 5 over x. Okay, so here we're going to get 1, and then this is going to be 7 over a very large number, which that's going to equal 0, and it's going to be divided by, so these are going to cancel out, and then we're going to get divided by 3, plus 5 over a very large number, that's going to be 0. So the limit as x approaches infinity of x plus 7 over 3x plus 5 is going to be 1/3. Okay. So our next problem is going to be the limit as x approaches infinity of 5x cubed plus 10x minus 4 divided by 3x squared minus 3x plus 7. So we're going to do the same thing and divide by the largest degree in the denominator. So we're going to get the limit as x approaches infinity of 5x cubed over the largest degree in the denominator, so x squared, plus 10x over x squared minus 4 over x squared. It's going to be all over 3x squared over x squared minus 3x over x squared plus 7 over x squared. So then this is going to equal, these are going to cancel out, so we're just going to have 5x, so 5x times infinity, that's going to be a very large number, and then it's going to be plus, this cancels out with this, so this is going to be 10 over a very large number, so it's just going to be 0, and this is going to be minus 4 over a very large number, so it's going to be 0, so plus minus, doesn't matter, and it's all going to be over 3 minus 3 over a very large number, so 0, and then same thing, so it's going to be 0, so this is just going to be infinity. Okay, and then, so I'm going to show you guys a rule that you can use to help you in solving these problems. So whenever the degree in the numerator is larger, so let's just do, actually no, let's do x to the a over x to the b. So whenever the degree in the numerator is smaller than the degree in the denominator, so whenever b is greater than a, whenever this is larger than that, the limit as x approaches infinity, or negative infinity, is just going to be 0. So that's a rule you can use to just kind of like help you out on your problems, so you don't have to do the dividing by the greatest degree in the denominator. So this is just going to make it a little easier. And likewise, when the degree in the top is greater than the degree in the denominator, so when this is larger than this, you're just going to have to go through that process. There is no easy way. But also, when a equals b, all you do is you divide the coefficient of a. So let's just say this was 2 and this was 3. So if these were the same degrees, right, if the largest degrees are the same, you just do 2 over 3, so the limit would just be 2 over 3. Okay? So, and then if this was, let's say, let's make a problem up. So if this was x cubed plus 2x squared, alright, for example, let's just say 5x cubed. and if this was 2x cubed plus x. So we know that the largest degree and the numerator and the denominator are both 3. So we can see that here and here. So then we can just say that the limit as x approaches infinity of this is going to be 5 over 2. So in this instance, it would be 5 over 2. So that's just a little tip to help you guys out on these problems to help speed it up. Okay. So here is our last problem. It's going to be the limit as x approaches negative infinity of root 3x squared plus 6 over 5 minus 2x. So we can see that this problem is kind of different because there's a square root. So since this is a square root and then the green here is x squared, you can think of the root x as equaling negative x. And the reason to this is that this is a limit approaching negative infinity, so this is why this would equal negative x. If this was positive infinity, it would be root x squared equals x. But in this instance, it will be this one, so I'm just going to erase this. Okay, so we're going to do the same thing that we did in other problems. So let me just write it out. Never forget notation. So we get root 3x squared plus 6. And this is going to be over x squared because of this, right? Large degree. And then here, we're going to do 5 over negative x, since it's approaching negative infinity. And then it's going to be minus negative 2 over negative x. So now let's just simplify this up. So this would equal the limit. So limit x approaches infinity would equal root, and then these would cancel out, so you have root 3 plus, this would be 6 over a very large number because negative infinity squared would just be positive infinity. So this would be a large number, so it would be 0. And this is all over 5 over negative x, so that's going to be over 5 over a large number, so that's going to be 0 again. And then these negatives cancel out, so like that. And the x's cancel out too, so it'd just be 2 plus 2. So the answer would be root 3 over 2. Thank you for watching, and I hope this helped you guys out. Leave a like, comment, and subscribe.